So in this stage of the webinar, what we want to do is take you through the actual heart of LabVIEW and creating your own autonomous code. As discussed, the example we're going to use is that of a line follower. There's several topics we're going to cover throughout this quick portion of the demo. First is front panels and block diagrams. And Greg referred to those quickly when we were looking at the sample autonomous code. But we're going to go into a little bit more detail, particularly about the block diagram. We're also going to talk about the functions palette, the context help, how to wire up Tetrix LabVIEW functions, while loops and case structures, and we're going to talk a bit about thresholds as well. So before we begin our coding, it's always excellent software engineering practice to make sure you clearly understand the requirements of what we're trying to do. So this is a very simple diagram where the black line clearly indicates the masking tape that would be on our white floor. And you can obviously see the representation of our robot. So the goal of a line follower is for the robot naturally to follow the shape of this line. And there are several algorithms you can use for this. And the algorithm you choose and the complexity depends on a lot of things, in particular the number of sensors you have. Well, in this case, we know that we have a single light sensor. So the choices that we have for the algorithm that we choose to use are relatively limited. So let's choose probably the most basic choice. Basically, what we're going to do in this code is we're going to have one of two situations. We're going to say the robot is either on the line or it's off the line. And if the robot is on the line, we want the robot to turn left. If the robot is off the line, we want the robot to turn right. And so if you were to imagine yourself as the robot following this line, you would be zigzagging approximately around the left side of this line as you followed it. So there's another piece of information here, and that's the light sensor value. Greg alluded to the idea of using thresholds. So we're going to use the number 50 to represent whether or not it's on the line. So if the light sensor reading is less than 50, that means it's on the line. If the light sensor reading is greater than or equal to 50, that means it's off the line. So please take this picture in your mind's eye as we proceed and as we go through to actually create this code. So let's jump into LabVIEW now. We'll leave our remote control editor. So we're going to create a new VI here in our program section. And when we click on new VI, we've got two choices. One is VI for NXT target, and two is VI for computer target. In this case, clearly we want to create a program to be run on the NXT target. It's important to note right now that we could go in and modify the autonomous code. But at this stage, since we created it based on the FTC template, it would require using a field control system software in order to make it run. So we're going to just create a brand new simple piece of code and not use the template for now. We're going to name this, we're going to just call it our autonomous line follower. And now we're into our LabVIEW code. And we see we've got our blank screen. So let's not have a blank screen syndrome. Let's make sure we know exactly how to get started. So as mentioned, there's two windows whenever we have a LabVIEW program. And those two windows are the front panel and the block diagram. The way to think of this is to use the analogy of the NXT brick itself or any other piece of hardware. That the front panel is literally the front of the box. So there'll be buttons, there'll be a screen, there'll be various indicators and controls on that front panel. But the block diagram is like the electrical circuitry inside the box. This is where we write our code. So let's begin at the very beginning. We'll right-click to bring up anywhere on the block diagram to bring up what we call the functions palette. Functions palette's got this little thumb pin that you see here, and if we click on it, that pins down our functions palette. LabVIEW uses a palette in a completely graphical methodology. You probably saw a quick introduction to that as we went through the autonomous code. But the basic idea here is that all of our inputs, all of our outputs, and all of our functions are represented pictorially on our block diagram. So let's think again about what it is we're actually trying to achieve here. We're trying to make sure that the robot is going to follow our line. So we need it to first drive until it hits the line. Then we're going to have it turn right until it's off the line, and then it's going to proceed into the line follower stage. So there's actually 3 steps to this code that we're going to create, and they actually get progressively more complicated. And if you want to see this in a little bit more detail, this is exactly the same process that's followed in the line follower extension of the Tetrix Getting Started Guide. So you can look at those materials, and their complete programming guides and solutions of each step there are provided as well. So that first part of the code, what we want to do is make the robot run forward, going straight, until it sees a light sensor value. So let's start at the beginning. Let's make that robot go. So within our functions palette, we've got a series of subpalettes, and we can just click on any one of them to make that subpalette appear. So we're going to start off, and we see here a whole bunch of options. And there's a lot of information to be had about these options, which we can conveniently get by clicking on the context help window. So there's a little question mark in the top right corner, and there's also a great shortcut. If you write down 2 things from this webinar, the second should be Control H. If you press Control H, that will bring up the context help window. When we hover over anything in LabVIEW, on the front panel or on the block diagram, we're going to get information in our context help. So the move motors, also known in more detail as the move DC motors, is exactly the function that we want. So if I were to place this function down, if I click on it once, the cursor turns into a silhouette of it. I can place it down wherever I want on our block diagram. So I place that down, and we now see a lot more information about it. We see that there are essentially terminals on this block. And in fact, that's exactly what they're called. There's a motors terminal at the top. There's a power speed terminal at the bottom left. And there's what's called an NXT terminal on the left and the right-hand side. We'll talk about the NXT terminal in a little bit. But let's start off by making our robot go. So if we need to make our robot go, there's 2 things we really need to tell our LabVIEW program. One is which motors we want to go, and 2, how fast. This is the great feature built into LabVIEW. When you hover over any one of these terminals and you right-click, a context-sensitive menu will appear. And when we do that, the choice that we're very often going to select is to create a constant. So if we do this now, LabVIEW will automatically create a constant here. I'm going to just scroll my window a little bit to the left. And what this has done here is this has created a DC motor constant. And from this constant, this is where we tell this function which motor or motors we want to make it move. So I click on where it says unselected. I've got some choices here. We can go into a lot more detail, and there's some advanced choices, but for now, I'm just going to choose a left wheel. And notice when I do this, that the Tetrix move DC motors function has not changed its state. What we really want to do is we don't want to move just the left wheel. We actually want to make the robot move forward. Moving just the left wheel will cause it to turn. So this triangle here will allow us to extend the motor constant and bring up a second unselected choice. Now, when we choose it, when we choose right wheel, notice what's happened is that the function block is automatically expanded to show 2 input terminals. Also notice the color scheme here. Left wheel is marked as orange or red, and right wheel is marked as blue. And there are 2 inputs here. One power speed input, which is red, and one which is blue. So it's very natural to understand that we can provide a speed value to each motor separately, or we can wire the same value to both of them. And in fact, what we want to do in this case is we want to make the motor drive forward. So I'm going to again use that trick of right-clicking on the terminal, choosing Create, and then Constant to choose a value. So I want the robot to start off going forward but slowly. So I'm going to put in a value of 15. Natural values for this are between plus and minus 100, where 100 is 100% and minus 100 is 100%, but backwards. And what we've got here is we've got a value put into the first terminal, but we do not have one into the second terminal. I could repeat what I just did and create a constant here, but really I want the same value, so there should be a way to connect this value into that input. And in fact, that's exactly true. You may have noticed that as I move the cursor around, its icon changes. Right now it's a crosshairs with a little circle, but when I hover over this, it turns into an arrow. And when I hover over this, it turns into a finger tool. Well, notice when I hover over any of these lines that are connecting our constant values to our function block, it turns into what appears to be a spool of wire. Well, that's exactly correct. The idea of connecting inputs, outputs, and functions within LabVIEW is called wiring. So whenever I want to wire, I click once on my starting point, and then when I move my mouse around, I can define where I want the second point to be. In this case, I'm going to click on the second bottom input, and now we've wired up 15 to both of them. So this process is called wiring, and you can do it by clicking on a terminal or on another wire. Also, there's a way to do this manually. From the View menu, if we choose the Tools palette, we can choose manually which function is available. Notice as I hover around that the Tools palette is automatically displaying which function is being selected. That's because this automatic tool selection has been turned on. If I click to turn that off, I can now manually select the tool that I want. We'll leave the automatic tool selection on, and I think you'll probably find in most cases that's just fine for you. So remember what we want to do in this case. We want to make the motor run until our light sensor reads a certain value. So the second piece that we need now that we've made our motor run is to read the light sensor value. So let's go back to our NXT Robotics palette. Under NXT.io, there's a whole bunch of choices. And the one that we want is under Sensor. So Sensor is and the type of sensor that it's called is polymorphic, which means multiple modes. Once we put down a sensor block, we click on this pull-down terminal to choose what kind of sensor we want. In this case, we don't want a touch sensor, which is the default. We actually want to read a light. And in this case, we're going to use read light, and we're going to choose the option LED on. Once we've done that, we need to, again, look at the context help and see what terminals need to be wired up. Well, there's a port terminal here. If we right-click, as before, create constant, we can define which port our light terminal has been connected to. And in this case, port 3, which is the default value, is actually the right value. So what's going to happen here, and we can read the context help to find out, but it's going to output a value. And that value actually matches the numbers that Greg showed us when we were looking at the diagnostics of the sensor itself. And this is, as we saw from our block diagram in the PowerPoint, a value that we want to set a threshold of 50. So what we're going to do is now use a thresholding technique on this value to make a decision. So in order to access that, we're going to go into NXT Programming, which is another palette within the Functions palette. And then we see here we've got a comparison set. What we're going to do is we want the loop to continue as long as the value is greater than 50. So we're going to put down our greater function. Oops, I missed it. Click again, comparison, greater. Place it down our block diagram. We want to wire the value read from the light sensor into the top terminal, which is going to allow us to say when the value is greater than something. Now we just need to say what that something is. We're going to create a constant of 50. So whenever you ask is something greater than or less than something else, the answer is always true or false. So we've got the resulting value of this, which is actually, if you look at the context help, a green wire. And green wires are not numeric values like the blue wires have been. Green wires are Boolean values. In other words, they're true or false. So we've got almost all the pieces we need here for the starting point of our code. The only thing we don't have is you have to think, well, I'm not going to just read this light sensor once. I'm going to read this light sensor over and over and over again. And for those of us with experience in programming, we know that's called a loop. And in fact, there's a couple different kinds of loops. But we're going to stay focused right now on one called, within the Structures palette, a while loop. And what a while loop does is it runs a set of code until a condition is true or false. And since everything is graphical here, it's a natural question for those of us who have experience with a text-based programming language. Well, how do we put a loop here? How do we wire it around? Well, the way that loops are done, the analogy within LabVIEW, is that loops actually encompass code. So if I click and I drag to create my while loop, and I'm carefully dragging to make sure it encloses all of the code that I've already created, we see here that we now have our functions inside our loop. And what that means is the stuff inside the loop is going to run over and over and over again. So we're almost done with this part of the code. We just need to connect up our logic here. So what we've got here is a situation where we want the code to continue as long as the value is greater than 50. So the last piece to understand about the while loop is that there's two different modes of it. We see that at the bottom here we've got a loop condition. The loop condition is how we tell the loop when to stop. So right now we see a stop sign inside there. That means a true value wired up will make the loop stop. We actually want it to be the other way around. So we can right-click on this function and change it from stop if true to continue if true. And finally, all we have to do to make this part of the code work is to connect up our greater than comparison to the actual loop terminal. So we spent a lot of time creating what seems to be pretty simple code, but it's important to understand that what we've done here is actually a huge part of what we need to do within the rest of our code. So remember, we're going to start off by making it drive forward until it sees the line, and then we're going to turn until it's off the line, and then we're going to do our line follower. So the second part of the code is very similar to the first. We just need to finish off this portion. So we're going to take our context help. Let's just get it out of the way. So press Control H to hide it again. What we need to do now is once this is done, we need to actually stop our robot. So the easiest way to do that is we could create this constant again. We could create this function again. But there's a great ability within LabVIEW to select some code, press the Control key, and drag it to make a copy of it. So now we've got another copy of our DC move command. And you know what we can do? Well, we can use the same constant that we created for left and right wheel. We want to wire it into this motor's terminal. So we click, we can route our wire so it goes where we want it to. Now we're defining the same two motors to behave a certain way. And now we can create a constant here because we want them to stop. So we're going to set a value of 0. And we're going to wire up the second terminal just like we did before. The next thing we want to do is we want to put a little delay in here. So built into our NXT programming, in the NXT.io section is the wait function. So what we want to do is after we've had our robot find the line and then stop, we want to wait just a little while, and we're going to create a constant on the time terminal of 0.5 just to give it a half-second delay. So now we're at the next most important thing to understand. This may be the third thing I want you to make sure you walk away with, is how do we know the order that this code is going to run in? This is probably the most subtle and initially important concept to grasp for new programmers to LabVIEW. Well, the way we've programmed it from left to right, it seems very natural that we've got our while loop and then we're stopping the code and then we have our delay. But in reality, if we were to run this code right now, there's nothing that insists that this delay happen after the robot has been stopped. We need some way to force the order of things. And one of the ways to do that is using the NXT terminal. So I mentioned it earlier. We have it as an input on the left and an output on the right of every function. So if we were to take the NXT terminal from our motor, DC motor command, wire it into the second one, and then daisy chain it from there into our time delay, what we've done is create a data dependency. What this means is this guy can't run until this guy is done. And this guy can't run until this guy is done. And in this case, this guy is a whole while loop. So what will happen is the motor's going to go to speed 15, and we're going to continually sit in this loop. Motor's going to stay at speed 15 until our light sensor reading is less than or equal to 50, is less than 50. Or equal to 50, sorry. As soon as that happens, then we're going to stop the loop, and then we're going to have a short delay. So what we want to do now is we want to expand this code. We want to go a little bit further. So we've found our line, and we've stopped. Now we want to turn. And we want to turn until we're off the line. Well, I'm going to just expand my block diagram here, because as you'll see here, we've actually got almost all of the pieces. In fact, we do have all the pieces we need. If I select and use this trick of making a duplicate, if I select my while loop, my motor stop, and my delay, and I press the Control key to make a duplicate, and I move it over here, and now I wire up my terminal constant, wire up my terminal constant, and my NXT terminal, I can change the behavior here. So what I want to do is I actually want the left motor to go, the top motor, which is the left wheel, to go a speed of 30. And I want my other motor to go the other direction, which is a minus 30. And what that's going to do is cause the robot to turn. And next, I'm going to read my light sensor, but I'm going to change my logic. I'm going to flip this around because I don't want it to go until it sees a line. I want it to go until it stops seeing the line. So there's a great ability within LabVIEW to replace a function really easily. So I've right-clicked on my greater than comparison function. I'm going to choose Replace, choose the palette that I want, Comparison Palette, and replace that with a less than or equal to. What that's going to do is have the opposite logic of before, and it's going to continue this loop until we're off the line. And then I want to stop it again, and then again have a short delay. So we've done the first two portions of our code. We've gotten forward until we found the line, we've turned until we're off the line, and now what we want to do is we actually need to do the line follower portion. So if you think back, and if we just refresh our memory by looking at this graphic again, the way the line follower behaves is it's continuously checking whether the light sensor value is less than 50, if so, turn left, and if it's greater than or equal to 50, then turn right. So we've got all the pieces we need, and this is one of the great things of programming with a good approach, with a clear algorithm, and one of the things that can be done really easily with LabVIEW is to make duplicates and slight modifications of our code. So let's go back into our code. We're going to need to create another loop, so let's do that. So I'm going to right-click to bring up my functions palette, or I could go to our functions palette that already exists, back to the programming and structures, create another while loop to the right of our code. I'm going to expand my block diagram a little bit. I know I'm going to need a little bit more room, so I'll make it about this big. We know we're going to need to read our light sensor again, so I'm going to just grab my light sensor and my comparison function, control drag to bring that into the block. And this time we need to do something different, whether or not the light sensor value is less than or equal to 50, or whether it's greater than 50. So this is the last structure, the last new structure we need in this code. And that's called a case structure. It needs to do something in this case and something else in that case. It's often called an if statement or a case structure in other programming languages. So that case structure that we need is again in our NXT programming, in our structures subpalette. We choose case structure. And just like the while loop, it's a container. So code goes inside it. So when we create a case structure, we're actually drawing a box. And inside this box, we're going to put our code for our true case. And by clicking on these arrows here, we can navigate to the false case. And deciding which case runs happens by this selection terminal. And because we know how this code is supposed to work, it's the result of this comparison which is going to decide which code runs. So in the true case, what we want to do is cause the robot to turn a certain direction. So we know, again, we've got a sample of this code. We're just going to take it, control drag, to bring it right into our case structure. We know we're going to need, again, the motor constant, and we know we're going to need, again, the NXT terminal, connect all that up. And in this case, the speeds that we want to give it are, for the top motor, 30, and for the bottom motor, for the top motor 0, and for the bottom motor 30. And in the false case, we're going to do the exact opposite, which is going to cause it to turn in the opposite direction. Now, there's a great shortcut for this. I've already showed you how we can click on these arrows to go to the false case. I'm actually going to show you this shortcut now. If we right-click and say delete this case, or we can even remove empty cases, then we can right-click on the true case and say duplicate it. So notice now in the true and the false cases, we've got the exact same code. So what we want to do now in the false case is change to do the opposite rotation, 30 and 0. We're almost complete. The last piece we need is for our loop terminal to actually run forever. So we don't want this guy to ever stop until you press the stop button on the NXT brick itself. So instead of creating and wiring up a Boolean value from a comparison, we're going to right-click and create a constant whose value is false, which means this loop will never ever stop. So for those of you who are new to LabVIEW, this has been a lot of information in a relatively short amount of time. But what I want to convey to you, and the thing that I hope you take away from it the most, is the easy ability to find information by pressing Control-H. The easy ability to find functions by bringing up and navigating through our functions palette. The way that we connect information together from functions to inputs and outputs using wires. The way that our cursor automatically changes to different tools depending on where we're hovering. We also talked about thresholding, using comparison functions to make decisions based on sensor values. And although it may be, what I definitely recommend as the next step is to go back to the Tetrix Getting Started guide material, which is online and available for you to look at right now, to pull down the sample programs from the line follower extension, which will be very similar, if not the same as the code that you see here. There's a lot more detail in the programming guides there, and I suggest that as a great way to get started. And I hope this was a nice introduction to the way that one can program and think about our algorithms using LabVIEW. So on behalf of myself, Ben Zimmer from Enable Training Consulting, and Greg Sullivan, and our colleagues at National Instruments, thank you very much for watching this webinar. We really appreciate your time. The next step for you to do is to go to tetrixrobotics.com/FTC and register for the next webinar. You can view this video offline for those who are attending live. And also, there's going to be all kinds of other information available on that landing page, the /FTC landing page. Thank you very much for your time, and good luck in this year's competition.